So, video 2, we're going to look at 3 things. Distribution, like what is the shape of the data, box plots, how do those work again, and then standard deviation, the basics. Okay, stay tuned, here we go. Second reminder on skewed right, look at the tail, tail's on the right. Skewed left, look at the tail's on the left. Approximately normal means pretty much symmetric. And then uniform means everything's about the same height. Yeah? Okay. Make sure you know what the answer is, because I'm about to tell you. It is B. Skewed to the left because tail is on the left. We're talking about box plots, and when we use box plots, we're talking about medians all the time. And when we custom BS, you have like what's the center, what's anything unusual, and one of the S's, of course, is what is the spread of the data. And so we kind of think of range as being the spread of the data, but we can really do better. We can talk about the spread of the data in terms of its IQR, or its middle 50%, if there's some kind of skewness or outliers. And then we can also talk about mean and standard deviation if it's kind of normal data. So here's your reminder about box plots. So they look like this. Sometimes you might have called them box and whisker plots. I'm taking out the whisker part because that's pretty normal. Uh-oh, I'm covering that stuff up. Okay, so a couple things to remember here. You've got 5-number summary. Your 5-number summary is your minimum, your Q1, your Q2, which is also your median, your Q3, and your maximum. That's your 5-number summary. From this, you can also get your IQR, which is the Q3 minus Q1. That's the middle 50% of the data. Remember, these are called quartiles. This is the first quartile. Quartile means 25%, second quartile, third quartile, fourth quartile. And then if you want to determine if any of your data has outliers in it, then you're going to multiply your IQR, that Q3 minus Q1, times 1.5, and add it to Q3, subtract it from Q1, and to determine if any of the data are outside of that range. Okay, so let's look at a couple of multiple choice questions that kind of deal with this concept. This one should be almost a gimme question because it's really just a little rote work and knowing where IQR is. So if you have not gotten the answer, go back, pause, listen, blah, 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 all the things. And then this is the answer. The answer is C. Should be 16, sorry. Remember, when I'm talking about a box plot, or when we look at box plots, the box is the IQR, right? The length of the box. So it's Q3 minus Q1. So it looks like it's about 3 to 19, which when you subtract, you get 16. And you might get something a little different than that, but you're going to get basically 16. So, all right, next one. That one was a little more wordy. I think if you just draw a box plot and put the numbers in for Q1, Q2, and Q3, it'll make a lot of sense. The answer for that one was A. So if I make a box plot where I put Q1 36.27, Q2 44.27, Q3 58.97, and I think about it in terms of its quartiles, it's 25 cents, right? Then you can very quickly see that yes, 50% is below $44.27 and 50% is above $44.27. Okay, so when we want to talk about mean and we don't want to talk about medians because maybe we have extreme outliers or extreme skewness in the data, then when we want to kind of look at the distribution of the data, we want to talk about the variability in the data. One of the things that we can look at is obviously standard deviation. And so I made you this like real pretty picture. Wait, here it is. Here we go. Here's your standard deviation reminder. So standard deviation is found with this really complicated formula or your calculator. So remember the symbols, the summation of, and remember this is the distance from the mean to each point squared, because we don't want negatives, divided by n minus 1, because really why are we talking about the distance from the mean to the mean? That doesn't make sense. So Remember, distance or average distance from the mean. That's what this means. Average distance from the mean. And then if we have normal data or approximately symmetric data, if we want to talk about standard deviation, then of course we've got this beautiful normal curve. And we know that 68% of the data is going to fall within one standard deviation. It's hard backwards. Within one standard deviation of the mean. And 95% of the data will fall within 2 standard deviations of the mean. 99.7% of the data is going to fall within 3 standard deviations of the mean. We've stopped using this so much when we could talk about z-scores, and you can still, of course, use z-scores to find this information. But if you know it's approximately normal, then this is a good sort of just, if they tell you something about standard deviations from the mean, then you can kind of think about this in terms of what's happening. But really the important thing here for the next question is, think about standard deviation as being average distance from the mean, okay? And since I messed up in the last video and I don't want to go back and redo that whole one, I'll say this. When you have extreme outliers or you have extreme skewness in the data, that's when you use medians. It's when you have approximately normal data that you want to go with means. So just to clarify, extreme outliers, skewness in the data, kind of stick to medians because they're not as affected by the those outliers or the skewness. Ready for the answer on that one? If not, pause, go back. Otherwise, the answer is B. Notice how we're talking about the most deviation or the largest average from the mean. Notice how there are no points at the mean. So that's going to really make it